Oh.
So if his
Just when you think
that
companies
he
can get
wouldn't
into
call.
work.
Now that was surprising. Like, you know, I like, kind of think they have, yeah. That was probably Anita and Ariba were part of it. Anita got it. Oh, Anita got it. Yeah, she got it. Because, okay, the two got it. I mean, you, not Ariba. Anita, Tin, Iridium, Nina. And, yeah, Nina got it. And then I think that's it. So like you 7.
Wait, so
Or
who's Nina, Julia?
10.
Alright, Sarah, sorry. I'm gonna record this.
Okay.
Yeah.
Thank you.
Bye, Godfrey. See you around.
Yeah.
Bye.
Take care of my children,
Wait,
okay?
Tuesday is much busier than
I don't let them go just anywhere.
Alright, so,
I know, but that's how it is.
So we're gonna go through this question about the last part of relay rate, which is deal with the angles. So we have a camera right here. It's looking at a rocket launch, and it's mounted around 3,000 feet from the launch pad. So 3,000. So this is a launch pad right here, and this is a 3,000 feet. So this is 3,000 feet. And a camera is needed to swivel as the rocket is launched and keep it focused. So as the rocket shoot up, the camera has to move in a certain speed. So if a rocket is rise at a vertical 800 feet per second, so vertically 800 feet per second, so that kind of tells me is a changing of height. So dHdt is equal to 800 feet per second. When it's a 4,000 feet high, and they kind of do this by purpose, it's kind of 3, 4, 5 triangle, if you can tell. Is 400 feet. How fast is the camera to the rocket? So how fast is the camera to the rocket distance changing? So we are looking at a dz/dt. Is equal to question mark when y is equal to 4,000. Okay, so that's pretty much it for this part. So here's a 3,000. So this one is basically Pythagorean identity. X squared plus y squared is equal to z squared. And then there's something that's constant. In this case, that the things are constant, I will plug in first, which is the x in this case. So it'll be 3,000 squared plus y squared equal to z squared. If I take a derivative with respect to time, that I'm going to get 2y dy dt equal to 2z dz dt. And now I got to do is plug in, because what we're trying to find, we have the dy dt. We have dy dt, in this case is dh dt, so we're going to say that's dy dt. Because we're going to assign this as a y, this is an x, and this is z. So we got 2y, so it'll be 2 times 4,000, I think. Dy dt is going to be, we know dy dt is 800. And equal to 2z, z in this case 3, 4, 5 triangle, so it's 5,000 times dz dt. And you can evaluate this. So roughly 5,000, 4,000, 3,800. So this one is going to be 2 is going to cancel out on both sides. 1,000 is going to cancel out 1,000 on this side. So it will be 4 times 800 over 5 is equal to dz dt. And 5, and this one's going to be 160, so it'll be dz dt is at 640 feet per second. And that's something we know already. Okay, that's something we know already. So this is a pretty standardized the triangle Pythagorean identity problem. Now the question says how fast the camera angle, so this is what the first time we had to deal with d theta dt, which is how fast the angle is changing. So the angle has to adjust and you have to shoot up and you have to go at a very certain speed. So how fast the camera angle elevation change at a moment in time. So in this case, part B, I'm gonna work on the sine. Can the camera see or no?
Yeah.
Okay. So part B, that we are looking at the d theta dt of the camera.
Now it's out of frame.
That's all the front? Okay. So I'm just gonna erase the middle part. No, that's okay, I'll just erase it.
Okay.
Can somebody give me an eraser? Good job. Okay, so this one's 640 feet, but we're gonna change to something that is on the bottom. We're gonna look at d theta dt. So which is this the main focus, because this is different than other questions. Again, we have 3,000 feet, and there's a 4,000, and there's a 5,000, and we have this angle that's forming. So the angle is changing. So in this case, I won't use the SOHCAHTOA, and I want to make sure the constant's on the bottom. So I have a couple options. I have sine of theta. So sine of theta is equal to what? Opposite, which is 4,000, which is y. Y is changing over the 5,000. But 5,000 is changing too, so y over z. So they're both changing. And I don't like to using this. So sine of theta is equal to y over z. Nothing is constant. What I will say is I prefer the constant to be on the bottom. Okay, prefer a constant on the bottom. So in this case, y and z both are changing. So I don't like this one. Okay, so I don't like the sine of theta. I'm going to try to change to cosine of theta. Cosine of theta is going to be 3,000. 3,000 over 5,000 over z. But in this case, I don't like this case as well because the 3,000 is on the numerator. I want that 3,000 to be on the denominator. So that's probably not a good choice. So let's do tangent of theta. That's equal to the y, which is over 3,000. Which is of all three choices that you see that 3,000 is the only one that I plug in because that's the constant I prefer. That something doesn't change, I'll plug in. But of the three choices, there's only one that's easier to take a derivative compared to the other one. So here's what I prefer is this one because I have denominator is 3,000 and this one's 3,000 over z. So in order for me to take a derivative, it requires z to the -1 power. In order to take a derivative of this one, I need to use quotient rule. So this is not the best option because there's no constant involved. This one has constant involved, but wasn't the best choice because z is on the bottom, and I don't like that. And z is also not something I'm looking for. I'm looking for d theta dt, and we have dy dt. So this is not an option that we're looking for. The reason why this 3,000 on denominator, that give me a lot of hint to start where that function is supposed to be. So now I'm going to do tangent of theta is equal to y over 3,000. I'm going to take a derivative of this functions, d to the dt. So I'm going to get secant squared theta, but I have a chain rule d theta dt. So that's the one I'm looking for because we're looking for d theta dt. We're looking for d theta dt when equal to y is equal to 4,000. So now after I take a derivative, now here is same thing saying the y over 3,000, that's equal to 1 over 3,000 y. So then I'm going to say 1 over 3,000 dy dt. Now what I'm going to do is I'm going to move the secant to the other side. So secant become denominator and it will change into cosine. So if I divide by secant on both sides, I'm gonna get d theta dt is equal to 1 over 3,000. I'm gonna plug in dy dt. dy dt is changing at 800 feet per second. So dy dt so I'm gonna multiply this by 800 and times by, if I divide by secant on both sides, so the same thing saying cosine square of theta. This 100 is gonna cancel out 8 over 30, so that's equal to 8 over 30, which is 4 over 15, so 4 over 15. So this part is gonna be 4 over 15 times cosine square of theta. Cosine square of theta is equal to adjacent over hypotenuse. So adjacent in this case is 3,000 over hypotenuse is gonna be 5,000. And then I'm gonna square it. So that's down to 4 over 15 times, am I out of frame again?
No.
Times 3 out of 5 squared. That's equal to, I'm gonna write it here, is equal to 4 out of 15 times 9 over 25. And I'm gonna simplify this, so which is 5 and 3, so it'll be 12 out of 125. That's radian per second. So radian per second. So in this case, it's gonna be 12 out over 125 radian per second. So hopefully that is gonna be okay. So again, 800 and 30,000, that's gonna be 4 over 15, because 100 cancel out, that's gonna be 4 over 15. Now cosine of theta is equal to this over this, so it'll be 3 over 5, so that will change to 9 over 25. So that's gonna be 12 over 125, which is radian per second. So that's it. Any question, Bridget?
Why is it not 1 over cosine squared theta? Oh, is it because you divide by secant
I
squared?
divide by secant on both sides, so if I divide by secant on both sides, it becomes times by cosine on both sides. So that's one of the questions that you guys might have problem with, and hopefully that's an angle. But here's the trick. Make sure if you set up using SOHCAHTOA's relationship, make sure the constant's on the bottom. This is the relationship you're using. You will not use this one, you will not use this one, you will use this one because the 3,000 is on the bottom. 3,000 on the bottom is a good choice. 3,000 on top, imagine that z, if you take a derivative of this one, it's gonna be z to the -2 power, which is, that's a pain in the butt. And you also have to take a derivative of cosine, which is negative sine, which is much more headache. But this is preferable, and you're gonna get a right answer. Okay?
Yeah.
You got it?
Mhm.
Question about this?
No.
Okay.
That's it?
That's it. That's the last part.
Bye!